and look at the discussion outline. What we hope to cover in this first webinar is a discussion of beach dune processes and the primary causes of beach erosion in Florida, a brief description of DEP's beach management program, and an overview of the Coastal Construction Control Line. Stein, our environmental manager for the Coastal Construction Control Line program, will present the beach dune processes. So thank you, Fritz.
Good morning, everybody. Thank you all for participating in this. This is critical for us because we think the beaches are important to all of us. I'd ask you to think about the beaches as the edge of our greatest wetland, our ocean, Gulf of Mexico and Atlantic and the Straits of Florida, and that convergence of the marine processes with the land. It's unique. You can see from this oblique aerial the expanse of sand and open area, critical for wildlife. We have an intuitive sense of this kind of linear estuary being important from its aesthetic and the scenic, and that is kind of tuned in, I believe, to its biological values for wildlife and the ecology of Florida. But really, why is it important to us and important to manage is because of our attraction to the coast. The beach tourism, the taxable property in the uplands, the jobs related to that are all add to the importance of its wildlife values and recreational benefits. As a line of defense, it is shaped by various factors. We see it most evident with the hurricane landfalls and the storms, northeasters, storms coming out of the Gulf of Mexico that put us all to work, and is why we're speaking to y'all through these webinars and these interactions. Think about, again, this long linear estuary where the marine influences the shape of the land, dominated by water, and think about the force of tons of water acting on small grains of sand and fairly fragile, although resilient, beach dune vegetation. While the water is the primary shaper of the shoreline, wind-driven sand and vegetation play a role in building the dunes that I'll speak to a little bit, which are the part of the reservoir of sand within this coastal system. In addition to the dune vegetation, think about the value of beach rack and the other biological components of the beach and how it all works together as a sandscape or a coastal system. To manage this resource, we have to understand it. We've created models of what it is like. This is a profile kind of cut through of the coastal system from the offshore area up into the bars in the near shore, the shore face, the beach and the beach berm itself, and the uplands that could be bluffs, dunes, or scarps. We've also modeled what happens during storms in a cross-shore sectional view where you can see that during storms the beach is moving. It's somewhat sacrificial as that sand moves offshore. It helps trip waves. You see that the dune system is contributing sand that's accreting offshore and kind of widening the beaches following storms. The coastal system, as we see it, is defined by the offshore area depth of closure of the movement of sand in a cross-shore kind of movement where sand can be moved up onto the shore face from bars, sometimes glomming onto the shoreline, or sand getting coughed up, wind then driving it across the beach into dune systems, storms breaching the dune systems, and then the landward extent of the coastal system being that landward extent of the major storm. Another depiction of this, this time on topsail, where you see an extensive coastal system here in its natural condition. Another way of modeling this and managing it is looking at the sand as a bank, so to speak. We get credits on the Atlantic coast coming down from the weathering of the Appalachians, the mid-Atlantic states giving us their sand as it comes south, driven by storms. And then as it moves through the system, it could be a debit when sand erodes or gets pulled offshore, or it could be a credit when it's pushed up into the dunes. You can see these dynamics at work at a place like Alligator Point in Franklin County. On the left is Alligator Point, and like the St. Joe Peninsula, it's referred to as a prograding spit. As sand eroded from the kind of headland, the Lighthouse Point area is pushed west, often by easterlies from the high pressure systems that build up through much of the year, or are pushed north to Bald Point. This is a close-up view of an accreting beach at Bald Point. On the left is an upland. Bald Point, I assume, was bald at one time, and all that vegetation of pines and oaks has grown since the Spanish and French were, sought bald. But this has all developed within the past 30 years, and we're seeing the old shoreline here. The trough has developed a marsh in it. There's another prominent dune ridge in here, and then again and again. This shoreline has been accreting at about 10 feet per year. We determined this by taking surveys over the years. You can see that 1980 shoreline and the upland, and then in the intervening years the shoreline going seaward, and it's gone seaward again as sand's been eroded from adjacent uplands onto it. This is primary adjacent upland, Lighthouse Point. Compared to Bald Point, you don't see a dune field out here. You see the woody natural communities immediately adjacent to the shoreline. This is a little dune down here. but it's signature of an eroding shoreline. Another way to see eroding shorelines is you see these beach roads along here. Then it was replaced and put along here. Then they moved it back and put it along here. And then they moved it back and put it along here. When it had problems, then they got to go through the state park at Bald Point. Very dynamic system. I know y'all are probably familiar with this. If you need to brush up, I pulled a book off of my boss's Tony's shelf. It's called The Beaches Are Moving, done by Kaufman and Pilkey back in the late 70s. They've also been associated with a series called Living with Florida's Shorelines, I believe. I would also refer you to the Ecosystems of Florida, edited by Myers and Ewell. Chapter 13 is Dunes and Maritime Forests, and it describes the geology, the ecology, and does a good job representing the different beach and dune conditions around the state of Florida. So these are kind of the natural processes, but then there that we can measure by shoreline surveys that have been conducted over the past 40 years, where you see the shoreline, the beaches are moving in eroded areas. They're building, moving in accreting areas. But it's kind of interesting how that profile is fairly consistent on the beach. And then you can see that the dunes themselves actually move, and they'll move into an upland area as long as they got room to move in their kind of rollover process. Gene's going to talk to you about erosion and how human activities have affected the shoreline.
Well, thank you, Fritz. Well, let's start with improved inlets are the greatest cause of beach erosion in Florida's East Coast. And no surprise, improved inlets disrupt the littoral processes and deprive sand from the downdrift shorelines. Looking at this particular aerial view, we see the very significant offset difference between the shoreline north of the inlet versus the shoreline south of the inlet. How do we address these issues? Well, we do that by first performing an inlet management study, and attempt to sort out the sand budget for that system. We develop strategies within that plan to try to put sand back on those downdrift shorelines. Those strategies may include simple things like putting beach-compatible sand from the maintenance dredging of the channel or sand traps onto the downdrift beaches. We may have a leaky jetty system where we're losing sand into the inlet and flood shoals, and so we fix that. But we also have to focus on the sand-deprived beaches downdrift and design and implement beach restoration projects. These projects, as they continue, do not address the total loss of sand within the system, but it is the best that this program can achieve to date. Another example, again in Palm Beach County, Boca Raton Inlet, and again we see the dramatic offset difference between the shoreline north of the inlet and south of the inlet. The second major cause of beach erosion for Florida, and this time we'll shift to the west coast, is our coastal storms. And these slides, I would say, are showing an undeveloped shoreline, North Captiva Island, both pre and post Hurricane Charlie. We see in the bottom slide where the island has been breached by the storm. All this are natural causes, and because this is undeveloped, not necessarily a terrible thing. But we go to a developed shoreline, and suddenly we do have problems. We see a pre-Dennis slide, the top left, Seagrove Beach, Walton County, and then we look at the bottom right slide, again post-Hurricane Dennis, and of course we appreciate immediately that Dennis must have been a very significant erosion event, and that we can confirm. But when we go back and we look at the top left slide, one thing that I note that's somewhat odd would be that where's the vegetation? I would certainly have expected that dune feature to have vegetation on its seaward face, but then, what I remember is 2004 we had Hurricane Ivan. And Hurricane Ivan was also a major hurricane and caused major erosion of Walton County. So Walton County was in a healing mode when Hurricane Dennis struck. And as a result, translated into problems, probably the most significant problem for Walton County since there's been a beach program in the state of Florida. A third cause of erosion, and the third cause is coastal armoring placed on a shoreline under erosional stress, and I emphasize the phrase under erosional stress. If it's a stable shoreline and I place armoring somewhere in that system, until it interacts with that storm, it's dormant. However, where I place that armoring on a shoreline with under erosional stress, I do have a problem, because what I've done is I've fixed the shoreline position, and as that erosion continues, I will lose the beach. And I've also isolated the dune system, which is an important component during a storm event. What caused the erosional stress? Well, it could have been an inlet. It could be Mother Nature wanting to straighten the shoreline, or there's some that might even say sea level rise. The next slide is the Summer Place seawall in Indian River County. This particular wall has a very long history with the program, but I'm not going to go there. I will note that post-Francis and Jean that I see, what am I seeing? I'm seeing a deflation of the back beach berm, the creation of a scour trough caused by Francis and Jean. If I look at the left arrow, sand elevation before storm, so I can see where the ground elevation was prior to the event. All this is of great interest to engineers in determining what the scour potential is and whether I design a wall correctly. What this slide doesn't show is the unarmored county park immediately downdrift of this wall that in essence decimated that park because of the NFEX. And although I spent an hour plus trying to find slides that would illustrate that, I failed, and I apologize. We're moving to the second point in our outline, which is the elements of beach management, and I have a series of bubbles here that show the regulatory programs, the local government fiscal assistance program, but let's start on the bottom left bubble, coastal data and analysis. That's our shoreline survey and monitoring, special studies, modeling, GIS. This is what Fritz previously mentioned that we have been doing for the last 40 years to monitor shoreline conditions, and so that we know where our eroding beaches are. And so we have had a survey element within the program for those 40 years, and those surveyors develop and maintain a geodetic control network. And so all our data acquisition uses that geodetic control network for controls, whether we're talking about topographic and bathymetric surveys, aerial photography, or in previous year LiDAR surveys. Then we have the beach management funding assistance, which I will just simply refer to as the grants program. It's a program under which we partner with local governments and cost share in correcting erosion problems throughout the state. Just a few statistics. We have 825 miles of sandy shoreline, 398 miles designated as critically eroded, and 222 miles managed and maintained. Typically, when we're talking about manage and maintain, and not always, we're talking about beach restoration and nourishment. So the photos that show, we have a pre- and post-construction photo of the Panama City Beach project, a very successful project, I might add. JCP, what are the activities? Well, we have beach restoration and beach nourishment, because I've already said those two terms several times. And apparently the program, when it says beach restoration, is talking about first-time placement of a sand for a project, and beach nourishment for the subsequent placements of sand for that project. Other things, the activities that the JCP program is engaged in are beach disposal of dredged material from navigation projects, shore protection structures such as breakwaters, groins, and jetties, and I'll note if it falls below mean high water, could also include seawalls. We have ocean fishing piers if they're new construction, and ports, the dredging for channel and berth and turning basins. But then we have coastal engineering. I didn't want to leave those folks out. And what I did was I'm showing a number of deliverables that the coastal engineering staff provide to our coastal construction control line program, since that's one of the focuses of this overview. And so they will provide us with 30-year erosion projections. And of course, we haven't talked yet about what that might be. We have storm erosion modeling. We have slope stability modeling. We have beach erosion assessments, and we have post-storm damage assessments. And if you're a coastal engineer, you get to wear snappy outfits during post-storm damage assessment events. We're moving to our third topic, which is the Coastal Construction Control Line Program. And the primary purpose of regulation under that program is to ensure the protection of the beach dune system, proposed or existing structures, adjacent properties, and the preservation of public beach access. And although I might disrupt the sequence of events here, just very briefly, since I'm not going to talk about it elsewhere in this webinar, is proposed or existing structures. What was meant by that? I'll note that until the implementation of the Florida Building Code in 2002, this program imposed construction standards for buildings seaward of the control line. It is the only regulation within the DEP that is now part of the Florida Building Code and is implemented by the local building official. So what the heck is the Coastal Construction Control Line? What is that line itself? It demarks the area of the beach dune system impacted by waves and erosion of a 100-year frequency storm. It represents the landward extent of Department CCCL regulation, and is established only on sandy beaches fronting the Atlantic, Gulf, and Straits of Florida. And each of those lines are established through a study process performed on a county-by-county basis. So, I'm to an Okaloosa pre-Opal slide, and here I want to reminisce a little bit before I talk about the slide, and just a little bit about the history of the program. In 1970, the legislature adopted Section 161052 of Florida statutes. The section citation irrelevant, but it was a 50-foot setback from mean high water. And the reason that the legislature implemented or legislated that was because of practices, development practices that were occurring. And those construction practices were the bulldozing of dunes, pushing those dunes seaward below the mean high water, and then surveying and staking a new mean high water for development. And so the following year, in 1971, the legislature then legislated the coastal, what then was called the Coastal Construction Setback Line. And it is the predecessor to the Coastal Construction Control Line program. So when I look at this particular photo, I see in the center of the photo a line identified as the Coastal Construction Setback Line, 1976. So as I mentioned, studies were done on a county-by-county basis, and so from 71 to 76, the only protection on this shoreline was that 50-foot setback from mean high water. And I'll make one further observation about setback lines. When they were studied and established, they were not equal from county to county. And what do I mean by equal? Well, if I look at this line in Okaloosa County, I see that, well, that setback line probably afforded protection to the beach and to the frontal dune. Not bad. If I look at other setback lines that were established in the state, and let me think about Volusia County, Daytona Beach. That setback was established immediately seaward of the seawalls so that people could go in there and maintain their seawalls without being bothered by the state. So the legislature then decided again to rework the program, and in 1978, redefined the program as a Coastal Construction Control Line regulatory program. No longer was there a setback, but instead we would use siting and design criteria to afford protection to the beach dune system, to proposed and existing structures, to adjacent properties, and to public beach access. Note that it doesn't say anything about endangered or threatened species. And so in 78, a new concept was defined where control lines would define the impact zone of a 100-year storm event. But they were studies again, and for Okaloosa County, the setback from 1976 to 1991 was the Coastal Construction Control Line in Okaloosa County. And then in 91, when the study for the control line was complete, the line was moved to the far left where it's identified on the photo. So a little bit of history, and now let's go to the next slide. And we see that post-Opal, and Opal we determined to be approximately the erosion event of a 100-year storm event, and the line that was studied for Okaloosa County didn't do a bad job in defining that impact zone. Okay, counties that have coastal construction control lines. We have 25 coastal counties that have coastal construction control lines, and we have 10 coastal counties that do not. 9 of those 10 still have that 50-foot setback from mean high water where there happens to be a pocket beach or a natural sandy beach. Now, we do have natural sandy beaches in the southern portion of Monroe County, and most of the regulatory activities that we see under that section of the statute occur in Monroe. There is very little activity in the Big Bend of Florida with regard to the 50-foot setback from mean high water. The next 4 slides I just simply wanted to show you some of the variability that you'll see in control line locations. So I selected Miami Beach, South Ponte Vedra in St. Johns County, Pelican Bay in Collier County, and Eastern Lake in Walton County. So I'll start with Miami Beach, and I see a solid black line, well, almost a solid black line, that runs from left to right across the photo and bisects, for the most part, the seaward row construction. And I see that that control line is located, well, geez, I have an engineering scale, that's about 800 feet from the mean high water. And so I say, geez, is that my landward limit of erosion there in Miami Beach? And my response, well, I think not. What has happened since that study was reestablished were beach restoration, beach nourishment projects, which have greatly expanded the beach face here. So the question may be asked, well, why isn't there a study done to reset it to a more seaward location? And the response back is the Florida statutes under Chapter 161 prohibits that. We do not relocate lines seaward where beach is widened due to a beach restoration or beach nourishment. Now we go to South Ponte Vedra Beach in St. Johns County. Again, I have that same black line. This time it's on the follows the east right-of-way of A1A. And I note that the distance between the control line and the mean high water or shoreline is approximately half of what we saw in Miami Beach. It's about 400 feet. And I suspect that if I ran the beach dune erosion models here, that the erosion limits would fall fairly close to that black line. Now I go to Pelican Bay in Collier County. I see something very different here. And the first thing is I'll note that, well, this particular control line was not established based on erosion. It was based on 3-foot wave criteria. So where the 100-year storm event carries that 3-foot wave is where that control line is drawn with some artistic relief in there. And then finally we have Walton County, Eastern Lake. And I'll note that the scientists that did the study here made an adjustment of the control line to account for the outlet itself and the acknowledgement that the planform or cross-section across that outlet is quite different than the cross-section in the developed areas east and west of it. And then under Florida statutes, Chapter 161 again, we have the agency has the ability to go in and reassess control lines when they are deemed to be ineffective. And generally, ineffective means that the control line no longer defines the impact zone of a 100-year frequency storm event, either caused by erosion or wave. So after the 2004-2005 hurricane seasons, the Florida Panhandle was in a beaten state. And so a cursive study was done to determine if any of the control lines in the Panhandle needed to be adjusted. And a decision was made that we needed to do minor tweaking in Walton County and some adjustment in Dog Island, Franklin County, and Cape San Blas, Gulf County. So in Walton County, I have what appears to be a gold line, which running left to right, that represents the original control line in Walton County. And then I see a blue, or what I'll call a blue line, immediately landward of the gold line, running parallel with it. But it's just a very small adjustment. In fact, in Walton County where we made these adjustments, the adjustments typically didn't extend more further landward than approximately 25 feet. On Dog Island in Franklin County, again, the gold line represents the original control line location, and the blue line represents the new control line. And so there, if we look at the right portion of the photo, we see that basically what we did was we suddenly captured the entire barrier island for that particular reach under control line jurisdiction. And then the third is Cape Sandblast. And I'll note that in for this particular study, this study would have been required even if 2004-2005 storms had never happened. Because on Cape Sandblast in Goff County, we see some of the highest erosion rates in the state of Florida. This particular aerial photo is close to Stump Hole, where we see erosion rates of approximately 15 feet per year. And if we continue south, and yes, the shoreline alignment in this area is north to south, onto the federal lands and proceed south, we see erosion rates that reach 30 feet per year. So, and I suppose to confuse everyone, in this particular instance, the orange line represents the new control line, not the old control line. And a solid black line represents the original control line, which was actually established in 1986. So we see a significant adjustment to the control line here on Cape Sandblast, and we move on. Just to talk very briefly, well, maybe not so briefly, about the CCCL and JCP regulatory programs. What separates the two programs? Well, the jurisdictional line is the mean high water. So looking at this simply, where we have activities that are seaward of the control line but landward of mean high water, those activities are regulated under the Coastal Construction Control Line Program. And where those activities are seaward of the mean high water, they're regulated under the JCP program. And just to note, where we're regulating something under the JCP program, under Florida statute, we cannot regulate that same activity under the CCCL program. So the next is a graphic, and the graphic, again, highlights that demarcation between the Coastal Construction Control Line and Joint Coastal Permits. But there's an introduction of a new phrase here called the 30-year erosion projection. So let's talk a little bit about the 30-year erosion projection. Going back to that history lesson, if we recall, back in 1978 is when the legislature amended the statute to redefine the Coastal Construction Setback Program to the Coastal Construction Control Line Program. So going from 1978 forward, there was no setback element to the Coastal Construction Control Line Program until October of 1985, when the 30-year erosion projection became law. And the 30-year erosion projection is a line of prohibition for major structures with a major exception for single-family developments. And I just suddenly lost my trend of thought, but I'll regroup now. And I don't really want to engage in talking about how the 30-year erosion projection is calculated. But what I do want to note is that that calculation is based in part upon what the mean high water elevation is and what is the tidal range for that segment of shoreline. And what that translates into in terms of where ultimately that 30-year erosion projection line is located, it has a significant bearing. So let me give you two examples. If I'm on the east coast of the state of Florida along the shoreline that's mildly erosive, so let's just say 1 foot per year erosion, and I calculate the location of the 30-year erosion projection, what I'm likely to discover is that the 30-year erosion projection protects the beach and perhaps the frontal dune area. So not too bad. However, if I go to the west coast, the Florida Panhandle, where mean high water elevations are lower and tidal ranges are less, and I do the same calculation for a segment of shoreline that's only mildly erosive, what I will discover is that 30-year erosion projection will protect the wet beach, probably doesn't get back to the back beach berm, and certainly affords no protection to the frontal dune. Laws and rules governing the coastal construction control line. So we have section 161053, which is the authorizing statute for the coastal construction control line program. We have section 161.085, which is the state's policy for coastal armoring. And then we have 379, which we'll talk about later. And then with regard to rules, I'll just simply, we have 62B33 highlighted in red. If you're interested in reading about some of the rules and criteria of the CCL program, that's where I would direct you. So what do we regulate under the CCL program? Well, most things, actually. Certainly all construction activities. And at the top of that list in terms of controversial is coastal armoring. We have post-storm emergency permitting activities, which are always very interesting, not only for us, but for the districts. Single and multifamily developments. We have a public infrastructure. There's always, well, there's very often dune restoration activities associated with development projects. We have beach cleaning, which, you know, over the course of the history of the program has sometimes been deemed to be not under our jurisdiction, and then other times within our jurisdiction. We are field permitting beach cleaning activities these days, and shorebirds are becoming problematic. Types of authorization: field permits, individual or standard permits, area-wide permits, general permits, emergency permits, development agreements, exemptions. The normal suite that you see with almost all regulatory programs. The one thing that ERP staff in districts probably already know is that the general permits and rules governing the CCL program are rather thin when compared to the ERP program. But just to talk a couple minutes about field permits, it has been a lifesaver for the program. Field permits were implemented in 1986, and we issue many more field permits than individual or standard permits in the CCL program. There have never been fees assessed for field permits, and they're typically issued on-site to the property owner or contractor. They're should be generally only for minor structures activities, and the maximum duration of the field permit is 12 months. When we get into the standard and individual permits, what are some of the siting and design considerations? And clearly, the program's most important task is siting. So appropriate siting of structures upland of the beach and frontal dune. Major structures sited landward of the 30-year erosion projection. And again, I'll note that there's a significant exception for single-family developments. And under that exception, those single-family developments must meet 4 criteria, and I'm only going to mention one. And that one criteria that I'm going to mention is that that dwelling must be sited landward of the frontal dune. Going on with considerations, limit excavation and manage excavated fill on site. That has become a monstrous challenge in southeast Florida, particularly in Dade County. Minimize removal or damage to existing dune stabilizing vegetation. Activities should not interfere with public beach access. And avoid take of marine turtle nesting habitat. And again, similar to other regulatory programs, we receive an application, we attempt to minimize impacts, what adverse impacts can't be removed, we attempt to mitigate for, and if we have significant adverse impacts, we deny the application. But unlike the ART program, there's no mitigation bank. And mitigation is certainly a difficult issue within the CCL programs. But what are a few of the things that I'm talking and not paying attention to my slide. Because the first thing I want to discuss is examples of minimization. And so what are minimization measures? Increase project setback from beach dune, reduce project footprint, minimize excavation and manage on site, avoid disturbance to native vegetation, downsize or remove ancillary structures that impact the frontal dune, and limit exterior lighting fixtures. Going back to what I was saying on examples of mitigation is that the control line program does not have a mitigation bank, and there are only a few measures that we can identify that meet the definition of mitigation. One would be dune restoration activities to include fill placement and the planting of native vegetation, removal of exotic plant species, removal of existing structures that adversely impact the beach dune system, and removal of exterior lighting and replacement with turtle-friendly lighting. And there's undoubtedly other mitigation measures out there. They're simply not on this list, and if you think of one, please tell me. Coastal armoring. Again, our most controversial of projects that we issue permits for. What makes coastal armoring problematic? Well, when you think about 161053, it talks about protection, preservation of the beach dune system. Considering, when we process and we assess, we want to ensure that that activity is not impacting an adjacent property. Well, coastal armoring and the coastal armoring policy kind of work against some of those initiatives. So what happens with coastal armoring? Well, we isolate the dune from the beach coastal system. So it does not play a role in beach dune recovery following a storm event. And during that storm event, if there's an unarmored property, and there's always got to be an unarmored property somewhere along that reach, that armoring will impact that adjacent property through end effects. But what 161085 attempts to do is balance the property owner's right to protect his home. And so it's always a difficult assessment that we go through where we, in essence, have an unarmored shoreline and we're introducing armoring to that shoreline. And that's exactly what happened here in South Ponte Vedra Beach. This was an unarmored shoreline until a half dozen or so years ago. And we had 1 or 2 buildings that were threatened after Francis and Jean. And so armoring was authorized. But that armoring cascade had a domino effect. It was then impacting adjoining properties, and in the course of about 3 years, we armored over 1,000 feet of shoreline. Emergency permitting. Again, I'm looking at Seacrest Beach in Walton County in the left photo, and Destin Point in Okaloosa County in the right photo. Even the most simple of permitting activities, such as beach dune walkovers, become problematic after a monster erosion event. And then, of course, where you're in a floodplain, which is what you have at Destin Point, it becomes problematic in terms of just accessing the building and putting back infrastructure. There's going to be much more discussion in the area of post-storm, and which will hold to future webinars and presentations. Of course, we have redevelopments, and redevelopments are the norm in Miami Beach. Under Chapter 161, what we're seeking when we authorize redevelopments is simply an improvement. Sometimes that improvement simply is taking the form of better building construction standards. But in the Miami-Dade reach, we have as mitigation our beach dune restoration project that was started in 1979 and has been very successful here. And we have public infrastructure, and I'll just simply note the last 2 items on that list are beach access ramps and stormwater outfalls. They can be very problematic within the CCL program. Beach access ramps typically signal beach driving, and although this program does not regulate beach driving, we do engage in the issue of ensuring protection to marine turtles and their habitat. A lot of interaction with the Commission on these kinds of issues, and of course, as we discover in future training sessions, a lot of interactions in post-storm events. Stormwater outfalls are very much discouraged. In almost every instance, when there's a stormwater outfall project seaward of the control line, we're talking about an outfall that exists, and improvements are being made to the stormwater facility itself, and we're not expanding the outfall. Dune restoration. We'll very often see dune restoration as mitigation for a development permit, and of course we'll also see dune restoration following post-storm storm events. Again, a topic that we'll capture multiple times during the next few sessions. Beach cleaning. again, an activity that is authorized by field permit. And I'm going to hold for a future slide as to some of the problems that beach cleaning present. But even though the program does not have jurisdiction with regard to shorebirds, beach mice, etc., we certainly attempt to do our best to account for those things, recognizing that we don't have jurisdiction over those species. So we talk about species, and what's our authority under 161.053? It's very limited. Once we establish jurisdiction for an activity, and we're going to regulate that activity, only then can the department, under the Coastal Construction Control Line, condition the nature, timing, and sequence of construction of permitted activities to provide protection to nesting sea turtles and hatchlings in their habitat. And then the other citation, 379, the department shall recommend denial of a permit application if the activity would result in a take as defined in this subsection. So again, we have very limited authority to afford protection to endangered, threatened species. But now I want to introduce an initiative that we began some 6 years ago, and that's an initiative to develop a statewide beach habitat conservation plan. As all know, I'm sure, under the Joint Coastal Permitting Program, under ERP, there's often a nexus to federal agencies for Section 7's incidental take permits. However, that nexus doesn't exist generally for the Coastal Construction Control Line program. So for the program to pursue an incidental take permit for activities authorized under that program, the other door is Section 10 of the Endangered Species Act, which requires the development of a habitat conservation plan. And what prompted senior management to take this path? Well, after the 2004-2005 hurricane seasons, the first example is Walton County. And under Section 161 of 085, Bold Lakes 3, the local county government issued temporary permits for coastal armoring that covered 18,000 linear feet of shoreline in Walton County, a majority of which did not qualify under our rule or statute. And then, other examples on the East Coast, and this is just a property, but it was a significant problem for us, was the beach quality, the sand beach quality issues, and potential impacts to turtle nesting. So as a result of those things that happened in the mid-2000s, we are moving forward developing a statewide beaches habitat conservation plan. We're in project year 6. The work group presently is developing minimization and mitigation strategies. We're redefining GIS-based alternative futures modeling project. I'll note that we'll be pursuing a 25-year permit. So in the futures modeling, we'll be looking at sea level rise and growth of development on the coast. We'll be developing proposed legislative change strategies and we're going to initiate work on a monitoring program for the approved HCP. To date, the federal government has granted approximately $4 million to the Commission and us to develop this habitat conservation plan. And with that said, I see we have 20 minutes left, and this ends the presentation, and we can move to questions.